So we're going to take a look at a slightly more complicated x squared function, one of the family of quadratics makes a parabola functions. So notice that this one is right 1 up 4, and then what does negative 2 do? The negative means upside down. The 2 means twice as steep. So instead of up 1, up 3, up 5, or in this case, down 1, down 3, down 5, because it's upside down. Okay, so for instance, and we'll verify this by plugging numbers in. I'm going to center it at 1, 4, because right 1 up 4, and it should be vaguely upside down parabola looking. So let's see if we can get it to be a much better picture than that. At 0, we have negative 2 times negative 1 squared is just 1. So that's going to be negative 2 plus 4. So that's 2. So the intercept is actually this. And again, like I said, down 2 instead of just down 1. Down 2 on the other side, that would be negative 2 times positive 1 squared plus 4. Negative 2 plus 4 is still 2. What happens if I plug in 3 or negative 1? Let's see. 2 times 3 minus 1 squared plus 4, negative, is negative 2 times 3 minus 1 is 2, and you have to square it first. Don't multiply before you do the exponent. Remember PEMDAS. E is before MD. So negative 8 plus 4 is negative 4. So down 2, then down 6 more. So 2, 4, 6, down to negative 4. And symmetric on the other side. So we have a much better picture now than our horrible yellow approximation. Okay, lovely. So now I'm going, and also where are the x-intercepts approximately? This is approximately negative 0.50, and this one is what? Around 2.50. So we'll plot those as well to help us. Okay, so what do we have? Switching things down, negative 4, 2, 4, 2, negative 4.
And the old x coordinates.
And then instead of negative 0.50, we have 0, negative 0.5, and 0, 2.5. Okay. Oh, look, it's not a function. We knew that. F inverse of 2 is both 0 and 2, for instance. Okay, negative 4, negative 1. I'm going to draw this in blue. Negative 4, negative 1 is here. 2, 0. 4, 1. 2, 2. Negative 4 and up to height 3. And then 0, negative 0.5, and 0, 2.5. Okay, so then we have our sideways parabola. So notice that's not a function. Finding the inverse algebraically, let me just remind you, you switch x and y. You solve for the new y. Move things closer later. So you peel things away from the outside in. Okay, so let's actually do that. So the first step is to switch the x and the y. So instead of y equals -2, we have x equals -2, y minus 1 squared plus 4. Okay, solving for y, what's the first thing to go? The furthest away on the right side with the y's is the plus 4. So I subtract 4. Then I'll divide by -2. Fine. Next step is square root. Plus or minus square root. And that's what makes it not a function, and that would give me the full sideways parabola rather than just half, which is what a square root function is. Now, move the 1 over. I usually put it in front so it doesn't get affected by the plus or minus. It's always just positive 1. Okay, finding the inverse algebraically. So first step, obvious step. Next, what do we do? We're going to multiply both. So we're going to move the 3 plus 5y to the other side of the equal sign. So multiply by it. So this is wrong. What's wrong with it? Well, you'll already see. You multiply the whole thing by x and not just the 5y. Okay, now what? 2 ways to go for this. I can divide by x or distribute the x. And I'll show you both ways. The divide by x thing only works if there's only one y. So So dividing by x, we have 3 plus 5y is 2 over x. Move the 3 over. Then divide everything by 5. Make sure you divide each term by 5. If you divide a fraction by 5, you put 5 into the bottom. Okay. Distributing x instead is a method that works even if there's a bunch of y's, so we'll have to do it on the next problem. But let me just show you how it gives you the same answer. So I'm distributing x to the 3 and to the 5y. Okay. Now, I want to move terms around so that the y is by itself. So I want to move things around, get rid of things that are stuck to y. Furthest thing is the 3x. So I'll move it first. Then I'm going to divide by what's stuck to the y. Is that the same? You don't have to show it, but 2 over 5x minus 3x over 5x. Sure enough, that is the same as that other version. All right, let's see what happens when you have 2 y's. Where am I getting 2 y's from? As soon as I switch into the inverse function, I have y on the top and I have y on the bottom. Cross multiply. Distribute, because I'm solving for y and I got y's on both sides of the equal sign. So I want to move terms around so that the y terms are on one side and the non-y terms are on the other side. Then we can factor y out. That's an arrow. Okay, so moving things, what do I need to move? Let's see, what's easiest? I think I'm going to move the negative term over and then move the 3 to that side. So 2x, I'm going to move the 3 over, becomes negative. Going to move the 7yx, it becomes positive. Now on this right side, I have y times what? Y times what to give you 7yx? Well, 7x. You can't lose the plus sign. Y times what to give you y? 1. Okay. Now, all we have to do is divide by what's stuck to y. And we have what we want. And notation.